Today, we're going to learn 3D modeling with SolidWorks. If you want to bring any design to life, you have to learn how to design parts. But I'm not just going to show you an endless list of features that you'll never use. What you need to understand is the general concepts of how parts are created and the tactics for how to apply them to any part you want to make. So I'll be covering 2D sketches operations, 3D feature operations, and show you how to prepare your parts for manufacturing with assemblies and drawings. I've been designing parts for 10 plus years, so I know these methods will work for you. If you're new here, I have a bunch of resources on robotics and AI, so make sure to check it out and subscribe for more. And thank you PCBWay for sponsoring this video. Okay, in this video, I'm going to talk about different options you can have for installing SolidWorks on your computer. So if you go to the SolidWorks website, you'll see a couple different options. You have commercial, academia, research, students and makers, and entrepreneurs, startups, and so on. So if you want to get a commercial license, usually these are several thousand, so I don't really recommend this. So for the next best choice, you're probably looking at the students and makers. So if you're a student, you could get a student edition for $99 a year. There's also like a cloud version. For the makers, you have here, you can start at $9.99 a month or $99 a year. And what this will do is it'll also install SolidWorks on your computer, but then when you launch it, if you go through the installation process, you're going to get an email that says like get started, and then you're going to get to this page. Then if you click SolidWorks connected, you could open up and it'll open up your SolidWorks. So one thing is every time you use SolidWorks, you have to go through this login, or you could create like a desktop shortcut that will also help you log in as well. So you could choose one of those options, see whichever one fits you the best. And then once you do that, you'll open up SolidWorks and it'll look like this. Okay. Usually it'll show the maker sign. I don't know why it's not showing it now, but if I close it and open it again, you should see it open up. So you can see it says the launcher, select the app, please wait. So if you wait a little bit, you can see that the SolidWorks connected is going to pop up. Okay, so it'll just take a little bit to load. And then once it's done loading, the SolidWorks window should pop up like we did before. And the startup time will probably depend on your PC. Usually, if your PC is pretty fast, it'll be faster. But see, you can see the maker sign here pop up. And then you also see down here in the bottom, it says SolidWorks Connected Maker and SolidWorks Connected here. Okay, so hopefully this video was helpful. If you found this video helpful, please give a like and subscribe, and I'll see you in the next one. Okay, in this video, I'm going to talk about how to set up your SolidWorks environment to have a dark mode feeling, especially if you're coming from code. You don't want to feel like you're looking at the sun. So there's a little drop-down little gear icon. If you go to options and colors, you have this background. You go ahead and choose dark. So automatically this looks way better. And then there's one more setting when you create a part. Right here, I already changed it, but typically by default, you're going to see this plain white, or actually the 3-point faded. So this one is kind of bright. Personally, I don't like it. So you could go here to appearance scenes. And then under scenes, you could go to basic scenes. So you could choose the different ones. For example, studio scenes, you have the different types. You have like light cards. This one looks pretty nice. Strip lighting, grill lighting. So there's a lot of different options. I think if you go to basic scenes, you can see this one here was a rooftop one. So to set it, you could just right click and then do set as default scene. And then that will get you can see the default keyword next to it. Okay. And if you want to add more, you could go to Manage Favorites and just choose the different ones you want. So the reason why I'm not using pitch black is because when you make, although it looks nice, but when you start doing sketches, it's like blue on black and it's kind of hard to see. So the next closest thing I found to be not too bad is the rooftop, but you could choose one that suits you the best. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one. If you want to bring your parts to life, PCBWay is the option for you. Go ahead and come up here to CNC 3D printing and choose 3D printing or CNC machining. Here I'm going to go through the 3D printing process. All you need to do is drag your part into this area here. So I'm going to drag my STL file. Once you do that, you can select the quantity. Here I'm going to choose 1. Now go ahead and fill out the remaining sections with a red star and then submit your part for review. Okay, in this video, I'm going to talk about sketches in SolidWorks. So a sketch is what is like the fundamental building block of how you design a part. So every time you start a design, you need to start off with usually a sketch in 2D. So here you have the sketch icon. There's a 3D sketch here, which you'll use in some cases if you're designing more in 3D, but for the most part, for beginners, people just use this normal sketch. So sketch is like the building block because you need to start off with something 2D, and then with the feature tool, you could create that 2D into 3D. So when you start off with a sketch, you'll create something usually that's like a closed contour, and then from there you could have a closed contour become something meaningful. Okay, so when you create a sketch, you usually want to choose a plane that you start your sketch off of. So usually I choose a plane that makes sense to me if it's, how I'm going to be looking at it. So in this case, I one of my preferences is to use the top plane. So you could come here and click sketch and create a sketch, or you could also right click the top plane and then just hit sketch. That's another way you could do it. So now that you have your sketch plane set up, you can see that this little button here is indented. So that's how you know that you're in the sketch mode. So here you could start sketching something. So once you do that, you could select one of these tools to make a sketch. So like, for example, you could have a line tool, you could create something like this, you could have a circle tool and something like this, right? You could have a square rectangle tool, something like this. So here you could just start sketching, right? But usually when people sketch, you don't have like random pieces floating. They should all be connected somehow. And they should all be centered in some location. So we'll go into details of each of these tools, but just for the sake of this video, you, you know that here is like a plane that you could sketch on, and you could see when I exit my sketch, I could also hold the mouse rolling wheel and rotate it. You could see my sketch in different views. And you could hit the space bar, you could see like this is my top view, my front view. So front view, you can see how that looks, right? So yeah, that's how you edit the sketch. So here I actually think the rooftop might look a little better. Yeah, you can see here based on which view you're looking at, like gray on gray doesn't look very clear actually. So usually by default it's just plain white. But I actually think, yeah, the sketch with this gray is actually a little bit better. So I'm gonna come back here and set that as my default again. If you look for basic scenes, it should be rooftop set as default scene. So I didn't like it originally because there's like little circles here, but we will just have to deal with it. Okay, so that's how you could create a sketch, and then you could come back here and edit a sketch. You could I'm going to do normal to, let's say you make a sketch and you don't want this, you could select that and hit delete. You could also select it and move your part around. I can move my circle around and replace it in different things. So those are different things you could do inside a sketch. So later on, we'll go into more detail on how to make a sketch proper. So we'll talk about different tools that can help you do that, okay? But hopefully this will get you started on what a sketch is and then how to add things to a sketch. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, I'm going to talk about the Smart Dimension tool in SolidWorks. So Smart Dimension tool is this button here you see, Smart Dimension. There's different things you could have. You have a horizontal dimension, vertical dimension. So those are all different dimensioning tools, but the smart one will kind of figure out for you what it's supposed to do. So the way it works is when you create sketches in SolidWorks, you could see that these lines, right, you could pull and drag them all over the place. So the degrees of freedom, if I could say, so degrees of freedom is just how many ways it can move, right? So if you think of a line, how many degrees of freedom does it have? You have like these 2 points here, each one can move in the XY, so both of these have 2 degrees of freedom. So you have a total of 4 that you can control. So you need to define them somehow to make it fixed. So maybe you could fix the location of this, so that's 1 degree. So let's say if I drag it to the origin, you can see this little yellow thing pop up. It will snap it. We'll go into that in the relations video later, but for now, you can see that the length is changing, right? So with the Smart Dimension tool, what that does is you could create a length associated with it. So let's make this 3 inches. Then now if I try dragging it, it won't let me drag because the length of this is actually now fixed. So I could move it, I could still rotate it, but you can see the length is not changing. Okay. And then maybe I want to have angle associated with it. So um, right here I have this 3-inch line and I want to dimension the angle. So I could also hit my right key and then this little thing will pop up. So hit right key and then drag your cursor up. And you could also do that or click the Smart Dimension tool here. So I could do angular dimension. So maybe this is 45 degrees. So you can see now that this line here is both dimensioned in the length and also the angle. Okay, so notice that there's a blue dot or a black dot here and there's a blue dot here. You might have to look really closely to see, but here this line can still move, whereas this line is fixed, and that's what we call this line as like fully defined. So if we exit the sketch, you can actually see here is a minus sign. So this minus sign here means that there's something that's not fully defined. We'll get into that in a later video. But for the scope of this video, I want to talk about using the Smart Dimension tool. So the Smart Dimension tool allows us to dimension either like angles, lanes, you have different things. So like the circle, I could dimension like the diameter of this, so make this 3. I could also dimension like a location, so I could say like, oh, this is how far from the origin. Maybe this is 2 inches, and then maybe the location of this. If I smart dimension, I could dimension like this way or in the x direction. So here I dimension this. Okay, so that's how you could dimension it, and based on the different situations, we'll see different ways of dimensioning, but the whole point of dimensioning is so that you can fully define something inside your sketch. Okay, so here, the only thing that's not fully defined is this length here. So just for the sake of completion, I'll make this 4 inches. You can see everything in the sketch is now black and solid. So if I exit sketch, you see that minus sign is no longer there, which means everything is good to go. Okay, so that's how you use the Smart Dimension tool to make your sketches fully defined. So if you found this video helpful, give a like and subscribe, and I'll see you. Okay, in this video, I'm going to talk about sketch relations in SolidWorks. So last time we talked about smart dimension, which is a way to dimension the length or location or angle of different features inside your sketch. So here with the sketch relations is another way that can help you define. So you can see when I hover my little pencil tool, you can see there's like a vertical and horizontal symbol that pops up. So usually anything in those little squares is the type of relation that it's suggesting. And this is the coincident relation here, this yellow one. So let's say I just create a line like this, right? So if I were to create a line that's starting on here, it will automatically make it coincident with the origin. So you can see this little green here. If I hover over it, it says that it's coincident, right? So that's one way to make it coincident. You can also click this dot, hit the control key, and click the origin. And you can see there's different relations you can add. So here you can make it coincident. That's another way. And you can see this green dot here pops up, which confirms that it's now a coincident relation. And then let's say you wanted this line to be vertical. You could click this and then you could either come up here and say make vertical or come to the side here and click vertical. I typically like to just come here and say vertical, and then you can see this vertical relation is now popping up. And let's say you change your mind with the relation, you could click that relation, so it'll now turn blue, hit the delete key, and then you could right click it and create a new relation like horizontal. So now it's a horizontal relation. Okay, so relations are good if you're working with like different things. So like let's say I had a different line here, right? And maybe I want this line to be parallel. So you could actually control and select two of the lines, and you could see that you have the parallel tool here relation. So you can see that both these have this parallel symbol. So this line is now constrained to be parallel, and I could delete it and click this, hit control, click this other one. You can see I can make it perpendicular. So now these two lines are perpendicular. That's another relation you have available. I could delete this and click that, control, click the second one. You can also make it collinear. So this will make this along the same line. I'm going to go ahead and delete that. You could also do, you could say equals. So now they're the same length. So you can see these are all different ways you can help fully define your sketch. So the ultimate goal is to just make it fully defined, right? But for here, let's just make like a simple example. So you could either dimension it or you could use relations to help you. So here, for example, let's say I want to make this 2 inches, and then this one, I could make this vertical, which will help me dimension it. So by making the vertical dimension, I don't need to specify the location of this point. So that's just another way to do it. And then I can also, let's say I want this to be 2 inches. Instead of smart dimensioning this, I could just make these two equal, for example. So that's one way of adding, modifying that. And if I could change this smart dimension to 3, and then everything will update. Okay. But the main idea is we could have a relation here that can help you fully define your sketch. So let's say we added a circle in here, and then there's another relation with circles and lines. You could make them tangent. There's also this fixed one here, which will show you. Well, let's do the tangent first. So I could click these two sketches, and I can make tangent. So now this circle is going to be always tangent to this line. Okay. And maybe I want it to be tangent to both lines. I could control click both and then make tangent. So now this circle is tangent to both lines. Okay, so you can see relations are pretty powerful. It helps making your sketches defined a lot more easily. And then I could also, let's say I want the circle to be contained inside, I could do something like, oh, there's also like the concentric tool. So, let's say I had another circle. Maybe I want these two circles to be in the center of each other. I could do make concentric or colradial. That would be something similar. So you can see here now I have two circles that's centered with each other. So instead of doing concentric, what I can also do is, if I were to move this, I could delete this, and let's say I made another circle, right? I could have this, the two centers, I can make it coincident. That will pretty much serve the same purpose. Okay, so there's a lot of different ways you can do it. But the main idea is you'll always see your relations show up here in the screen, and then you could use that to your advantage to fully define something. Okay, so you notice that this circle has one more degree of freedom, which is the size. So we could use our smart dimension tool here to make this 3 inches. And now this thing is fully defined. Okay, so you can see that there's no minus sign here anymore. So that's how you work with sketch relations. So if you found this video helpful, give it a like and subscribe, and I'll see you in the next one. Okay, in this video, I'm going to talk about the line tool in SolidWorks. So previously we started using a line tool, but we didn't go too in depth about the line tool. But here we're going to go into more details about it. So typically you would use a line tool if it's something that you can't draw. Like let's say if you were to make a rectangle, or like a polygon, for example. So if it's any of these two shapes, you wouldn't want to use a line tool to make it. So anything that you can't create with a rectangle or a polygon tool, you could use a line tool. So you could make custom shapes in 2D, or you could use a line tool in 3D too. But here we're talking about 2D. So we're gonna go ahead and sketch on the top plane. So if you look at the drop down, you have 3 types of lines. You have a line, a center line, and a midpoint line. So a line is like a solid line. So solid lines can help you form a contour, which we'll use in features later. And then center line is usually good for like reference sketches. So here we can see center line has like dashes between the 2 points. So you could use it for references. And then you have a midpoint line, which you start from the center point and then you could stretch out however long you want it. Okay. So those are the 3 types of lines, and the different times you may want to use the 3 types. So in here, if you click line, right, you could also change a normal line into a line for construction. So now these 2 lines are pretty much the same. They're both like dash lines. So here you could click it. You could also make a line an infinite line, so this will make it go on forever. So you could click this to adjust. And then you have like additional parameters here. You could specify like where you want the X, Y. I usually don't touch this stuff, but if you want to be very specific, you could use this as well. But usually I'll just use a smart dimension tool instead. So midpoint line is good if you know the center point of your line, for example. So here you could create this midpoint line like so. And there's also a point in the middle. So you could delete things. You could also hit Control Z to undo it. So here we just have like a midpoint line, right? So let's look at an example where you may need a center line. So let's say we create, um, let's say we wanted to do like a rough sketch. So we have like a center line, and let's say we have some shape here, like this, right? So maybe you just have some shape, and then maybe you want to use this as like a reference. So maybe you only want to connect part of it for some reason, and then you only want to like block off part of it. So this might be an example where you use a center line where you might have like a main sketch that's happening, and then on another sketch you may reference that. So actually, let's do another example. So let's say I'm making like a U or something. Okay. So I'm making a U. Okay, so I have a sketch like this, and then maybe this is just a reference, so I could select everything. I could say for construction. Then I have a construction sketch here, and then I could create another sketch on top, and then maybe I'm gonna do something here. So let's say I'm sketching some trapezoid here for some reason, and then maybe I want to create another sketch on top off of that same reference. So I'm gonna do something like this. Okay. So that's how you could use different sketches. Here I have 3 sketches, and I have like a reference sketch in using construction, and then from there I just sketch my other sketches on top. Okay, so that's one application. So you can also roll over and suppress everything. And so those are for lines and center lines, and then midpoint lines is just good if you know where your center is supposed to be, and then maybe you could just dimension like half of your line, for example. So you could say half of my lines can be 1 inch, and then maybe I want this to be horizontal. So that would be a good way to um, also have your line center at the origin. That's like another way you could do it. But you could also like create a line like this, and then there's a line that pops up here. You could also make coincident, and then you could also make that the origin. So it just really depends on your application. There's certain cases where you might find one more handy than the other, but really that will just come with experience. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, I'm going to talk about the rectangle sketch tool in SolidWorks. So here you can see there's a rectangle tool, and there's different types. We have a corner rectangle, a center rectangle, a 3-point corner rectangle, a 3-point center rectangle, and a parallelogram. So here we're going to sketch on the top plane, and then go to normal 2. You can see here we have our normal rectangle here. We have a center point rectangle. So with the center point rectangle, you'll have these 2 dashed lines that goes across from each other. I have a 3-point rectangle, so you'll select the first point, second point, and third point. And this is good if you have a rectangle that is not typically oriented where the side of these lines are either horizontal or vertical, as these 2 are shown. That's why it's shown in a tilted. And then you have a 3-point center rectangle. So this one is good if you know the center location. So this is pretty much like this version, but rotated. So you could think of those 2 as like equivalents, kind of. And then you have the parallelogram. So you could click 2 points and then drag. That will give you your parallelogram. Okay, so those are the different types of rectangles you can have. And then if you select this rectangle, you can also have different parts of your rectangle for construction. So you can see here that if you click one line and then click for construction, then you could have different segments for construction if you wanted to use that for reference. So notice that when you have something for construction, it's no longer a closed contour, whereas they're all solid lines. That's going to be a closed contour. Okay. So that's how you could have rectangles. And if I select it, you could see that You could have different things to define it. I could turn a normal rectangle into a parallelogram if I were to delete these relations. Then really this just becomes like 4 lines connected to each other. So really what a rectangle is 4 lines connected together for you with certain relations defined for you. So it just makes some of your dimensioning a little bit easier. So let me just go ahead and create a simple rectangle here, the corner rectangle. So usually when you start designing, you want your rectangle corner to be aligned with origin. So to fully define this rectangle, all you really need is to define a length and width. So I could smart dimension this to be like 4 inches and then the height to be 2 inches. Then you could see my sketch has no lines here, then you know that my rectangle here is fully defined. Okay, so that's how you could make rectangles, and you could also, add more rectangles on top here. So maybe I wanted to make some other shape like this. You could um, create more rectangles like that. So you could stack them up any way you like, and then you could define them to be some length. So I'm just gonna go ahead and define these. Okay, so you could create different shapes as well. So notice here that sometimes you may want like a full contour to pass through. So this is where another instance where the construction line might be useful. So I might make these 2 construction lines, and then this one should also be a construction line. And then here I want a solid line, so I could come here to my line tool and just close off that contour, and then here I could close off this contour. So now I could have like a full like T solid shape with nothing in between. So I could do it like that, or you could also just you could make the same thing here without the rectangle tool. If you just come to a line, maybe you could just create something like this. You could just click, um, and this will give you something similar. Okay, and then you go ahead and dimension each part. The only thing is, you may have to do a little bit more dimensioning because the rectangle tool helped you kind of set up some of the relations already. So in SolidWorks, there's usually a million ways to do the same thing, but just with practice, you'll find which way works better for you. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, I'm going to talk about the circle tool in SolidWorks. So the circle tool for sketching is, as the name suggests, to make circles. You have the circle and then you have the perimeter circle. So if you're trying to make holes for screws, you typically don't want to use a circle tool. There's a hole wizard that we'll talk about later. So these are good for non-hole screws that are used for screws, or any sort of holes that you may drill. You don't want to use the circle tool. So these are usually for like custom circles, or if you're trying to create a body that's a circle, you want to use this tool. So you want to see case by case when it's appropriate. So we go ahead and go to the top plane and sketch here. So if you go to the circle tool, it's pretty simple. You have a main center point, and you could just stretch it out to specify the radius. And you could choose the different types here, perimeter circle. That's like the same as changing here. But you could see that to fully define a circle, you could have the location of your circle defined. So here I'm making it coincident. And then you could define the diameter. Okay. So if I exit the sketch, you can see the circle is fully defined. And that's how you fully define a circle. And then if I come back to edit sketch, you can also make this line for construction. So now this is a construction sketch if you want to use it for reference or something. Okay, so I'm gonna go ahead and suppress this. Yeah, so suppressing is like another thing you could do with sketches. But I'm gonna come here and look at the perimeter circle. So perimeter circle, you can see you start off by a point on the perimeter, and then you click another point, and then the third point will stretch the size of it. Okay, so that's a perimeter circle. I actually don't use a perimeter circle too much, but I can see there's some cases where you may use a perimeter circle if you know where um, the edges of your circle needs to go. So perhaps you have like a center rectangle here, and then maybe you know where the edges of your circle is, so you might click like this, and then maybe another point here. You'll have like 3 points of your circle tangent to the edges of your rectangle. Then that could be an example of having a perimeter circle. And you can also make these lines for construction. Just gonna control and select all of it for construction like this. So you can see that's where a rectangle can be useful for creating a construction. So you can see here, this is like how you would define that for a perimeter one. And maybe you already know the box is some dimension. Again, I'm just gonna choose some random dimensions here. And you can see because the tangent dimension has already been defined, um, this whole sketch is actually fully defined. So you're actually all set. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, I'm going to talk about the point sketch tool. So point is it's just like something you could add onto your sketch, usually for like some sort of reference. And when we were using the midline point, as you recall, by default, there's a point that's created in the middle, right? So let's say we wanted to create our own midline tool. We could draw a line like this, and then we could come to the point and add a point in there. So this is essentially our own midline sketch, but we're not limited to where this point is. Maybe you have like a fancy circle you draw somewhere like this. Let me do a normal circle actually. Let's say you have a fancy circle and then there's a special point on here that you want to reference and you want to make that point like tangent at that point or something. Then that's where creating that point might be useful. So points helps you connect another sketch to another part of it, connects like two sketches together at a very specific location. If sometimes it's hard for you to dimension it directly, but that's one common application of a point. And then visually too, it helps you see like where you're trying to connect the thing. So I think it's both like style and preference, but sometimes it's useful to just have a point in your sketch. Okay, so that's how you do a point in SolidWorks. And if you found this video helpful, give it a like and subscribe, and I'll see you in the next one. Okay, in this video, I'm going to talk about the mirror entities tool in the sketch. So for mirror entities, it's when you create something and you want to have it have a reflection about some axis. So we're going to go ahead and create a center line, and this will be our main line that we're going to be mirroring about. So let's say I made some random sketch here, and I want to mirror this. So I would say mirror entities, and then mirror about, then it mirrors over like so. Okay, so maybe this is a butterfly, kind of looks like a butterfly. But you can see that if I make a change on one side, then it'll update accordingly. And all the dimensioning rules that we talked about will apply. So right here, we're mirroring it about the center line. You could mirror it about any other direction. So you could go ahead and play with that. But that's pretty much it for mirror entities. It's great when you have symmetry, and that way you don't have to duplicate both the right and left 2 times. Okay? So if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, we're going to talk about sketch patterns in SolidWorks. So sketch pattern is a way you can repeat a certain sketch um, over along, in the linear case, the XY direction. And it's good for just any sort of pattern, like maybe you have plates with a lot of holes, maybe you have a pattern, or maybe a plate with a bunch of like cat faces or something, you could pattern that. Basically, anything that's repeating, you could use a linear sketch pattern. So we're going to go ahead and start a sketch here. So let's say we have a square, or actually, let's use a rectangle because I don't want the stuff in the middle right now. So inside, let's say we have like this weird, let's just make like, we'll make a little cat. Okay, this is our little cat shape here. And to make the sketch pattern, what we can do is we go ahead and select this, and then linear sketch pattern, we need to select all of this. So I think right now, because it's inside a square, it's not really letting me select so easily. So you have different options here, the different axes. So you have X, Y, and you have the amount of spacing you have here. So you also have how many times it repeats itself, and then same thing in the Y direction. You could specify here how many times you want the Y to repeat. So let's say you have 2. Keep increasing this, but here we want to switch directions. So you could press this to switch, and then I want to increase that. Okay, so that's how you could dimension something linearly. And if you hit OK, you can see that now you have a bunch of cat faces. Okay, so that's for the linear sketch pattern. And then for the circular pattern, let's actually just keep the cat. Okay, so for the circular one, I'm gonna move this here. So we could go here and choose circular sketch pattern. And then here is the center point. So I'm just gonna choose the origin. And then entities to pattern, I'm gonna choose, actually, let me just select this. It'll be a little bit easier. And then circular pattern, then you can see that I have my pattern. And you can also say maybe there's certain instances you want to skip. So you could do that as well. Maybe you want to skip um, more than that. So you could go here and click that. So you could have like an irregular pattern that's skipping certain instances. So those are just other options you can do. And then if you want to undo that, you could just go here and delete it. Then you'll have your normal pattern for the circular pattern. Okay, so that's how you can do a circular pattern, and then we also talked about the linear pattern. So those are good for any sort of repeats. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one. If you want to bring your parts to life, PCBWay is the option for you. Go ahead and come up here to CNC 3D printing and choose 3D printing or CNC machining. Here I'm going to go through the 3D printing process. All you need to do is drag your part into this area here. So I'm going to drag my STL file. Once you do that, you can select the quantity. Here I'm going to choose 1. Now go ahead and fill out the remaining sections with a red star and then submit your part for review. Okay, in this video, we're going to talk about features. So we finally finished sketches. So now features, that's really the core of designing solid models, because what features do for you is it essentially adds or remove materials based off of your 2D sketches. So the bulk of these features here will do that for you. And then we also have like the fillet, which we'll talk about later. You can also do patterns, There's other special ones too, like rib, draft, shell, wrap, intersect, and mirror. And then you can also do things with reference geometries. Okay, so stay tuned and we'll talk more about what each one of these do in SolidWorks. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, so in this video, we're going to talk about the Extrude Boss Base feature in SolidWorks. So what this does is it'll take a 2D sketch and then make it 3D by taking that profile and extending it normal to the surface that it's drawn. So that's really the fundamental building block to building 3D objects in SolidWorks. So let's go ahead and just create a simple object like a circle. So once you create a circle, and notice I'm not always going to fully define these quick demos, but you guys should be in the habit of doing that. But just for the sake of demonstration, you could see that here we have a cylinder that's been extrude bossed, right? So that's pretty simple. So here you could drag it if you're eyeballing something, but if you know the exact dimension, you could type it in. And you could also add like a draft here. So you can see what a draft is it'll taper it on one end. So that's the angle of the draft. Or you could draft it outwards. And then you can also extrude boss the second direction. So maybe you have two directions you're extrude bossing, okay? So it's really up to the design preference. Usually I extrude boss in one direction, but there may be special cases where you want to do both. And then usually by default, if you have a sketch like this, you don't need to select a contour. But if it's a more complicated one and you have like different parts of the sketch that you want to extrude boss, then that's where that would come in. Okay, so let's say you screwed up, you could delete this. If I come here and add another thing to my sketch, so I'm gonna come here and go normal. So maybe you have like two contours here, right? And you only want to extrude boss one of them. So that is where the selected contours would come in. You could choose which contour you want to extrude boss. Okay, so that's what that is. But let's go back and look at just our single circle case. So in our single circle case here, when we were trying to extrude boss it, there's different options. You have your sketch plane, a surface plane. So sometimes if you have like a different place that you're sketching off of, you could choose these options accordingly. But here you could have like a up to surface, offset from surface, up to body, or mid plane. So again, these are useful when you have other features that's already present. So let's say we have this block here. Okay. And then maybe on the same top plane, we're gonna make another sketch. So let's say we're adding some rectangle feature here that sticks out. Okay, so maybe we want to extrude boss this. So if it's blind, it'll be some distance, but you can also say like up to surface, then you could say I want it to be the same height as this. So that's what the up to surface is. And that way, if you modify one of the features here, let's say you made this a little bit longer, then this other additional feature will adjust with it because it's going along with that surface. But if you come back here and made this blind, so let's say it's 3 inches, then in that case, if you change the height of one of the items, the other one won't follow with you. Okay, so that's what these options are for. And then you can also change the direction of your boss. You could make it go the other way. And then you have these other special cases that you could have like through all. In this case, through all doesn't make sense because it'll just go on forever. So it just doesn't show it. You could do like up to body if there's like a certain body, but here the surface makes more sense. So you could play with those different settings, but the blind and up to surface I would say are like the most common ones that I use. So that should get you started for the Extrude Boss feature. And another thing to make note of is you could really extrude boss in any direction. So here we're doing it in one plane, but you could go ahead and, like, let's say you make a sketch on this plane. You could, let's say I sketch a circle here. I could go ahead and extrude boss this surface here. I'm gonna do a blind one. So I can make, I could extrude boss in like literally any direction. As long as you have a surface, you could sketch on the surface and you could do the extrude boss on that surface. Okay, so it's really flexible in terms of what I can do, but really the core concept is you have a sketch and then you make it 3D by stretching it out normal to it. Okay, so that pretty much summarizes the Extrude Boss Base features, and as you design more, you'll see different ways you can use this. Okay, so if you found this video helpful, give it a like and subscribe, and I'll see you in the next one. Alright, so in this video, we're going to talk about the Extruded Cut feature here. So in order to use the Extruded Cut, we need to have a body to cut into, and Extruded Cut has plenty of applications. Pretty much anytime you want to remove material, you'll be using the Extruded Cut. But to begin with, you need to have a solid body. So let's just make a square here. Okay, so you could make a square, and then we're going to extrude boss this. And this is our feature of a body. And then to make extrude cut, typically you'll need to have some sketch. So we're gonna make a quick and dirty sketch here of our ghetto Tesla logo. So we could go here in features and extrude cut, and we cut through. So this is our ghetto Tesla logo that we sketched up really quick. Okay, so notice here in the extrude cut, there's different settings you could have. You have the blind, which you could specify a specific distance. So let's say we have 1 inch, then you will have a 1 inch cut. If you go back here, you could see there's different options. You could have like a through all, then it'll go all the way through your surface like we had before. And if your blind is past your thickness of your part, it's gonna act as a through all. So that's what happened earlier. You could also do like up to a surface. You know, let's say you created a plane here. I could select these two surfaces and then create a reference geometry of a plane. So here we have a plane, and then we're gonna drag this plane so it's before the extrude cut, so we could actually use it. But here you could say like up to surface, and then you could click your plane 8. Then you could see that it'll cut up to that plane. Then you could if you could adjust the location of this plane. So maybe here instead of a midplane, we just want it to be offset. So you could offset it to, we're gonna offset a different direction here. Flip offset. So you could specify where the offset is, and then the cut will go up to that. Okay. So you could come back in here, and you could also edit where you want to have your you could edit the sketch here. You could edit the sketch plane. Maybe you wanted to sketch on this plane instead, then that will happen. But sometimes if your direction is wrong, you might get an error, so you need to update the direction, for instance. So now it's working. Okay. So there's a lot of different things you could do with that. But pretty much extrude cut will just allow you to cut anything you want. And yeah, so we'll go through more examples later on, but this should get you started with the extrude cut feature. And if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, so in this video, we're going to talk about reference geometries in SolidWorks. So reference geometries, what it does is it can help you create planes, axes, coordinate systems, or points. So planes especially is useful if you're trying to create certain features like the swept boss base, the lofted boss base, or the boundary Boss Base, or if you want to do any of these other features on a different plane, it's always useful to create additional planes. So we'll take a look at how to actually do that. So to make our lives easier, let's just create a box first. Let me center this. Okay, so we'll create a simple box, and we could go ahead and start adding planes to this. So if I click the plane tool, you notice that there's a new plane that showed up. So I could offset my plane. So this could be a additional plane that I may want to sketch on that's not on the existing surface. I could do other things too, like let's say I delete this. Maybe I want it to be some special angle. Here I could add an angle here. So I could add a special angle to this. That's another thing you could do. So there's a lot of different things you could do with planes and how you orient them. And, don't be afraid if you don't know what these mean. Sometimes I get confused as well. But the best way to do is just click and try, and then if it doesn't work, try something else. Okay, so you could have like vertices, for example. Like, see, right now I'm doing something like this. And maybe you have, oh, so the angle here doesn't work, then you know that you don't want to do that. Okay, so you just go ahead and play around and see what works and what doesn't work. And then once you play with more of these, you'll get a better idea of, what you're supposed to do and what you're not supposed to do. But really, ultimately, what it comes down to when you're designing these planes is you want to see like what are all the degrees of freedom available, right? So here you can see that that's not really working too well. So there's a little bit of trial and error, and then worst case is if you're trying to do a very special plane orientation and you really don't know how, then you could just Google it. Okay, but the ones I showed you are probably the core things that you'll need. Is you'll offset a plane off of an existing face, or you want to angle something. So those two are probably the most common ones. And then for an axis, you could do other things too, like a point and a face plane. You have like a 2 points vertices, you have two planes. So there's a bunch of options, right? You could also just select an edge and you could create an axis. You could, drag this and so on. Um, there's like the point and plane option. So maybe perhaps I add a point somewhere like right about here. So I have a point, and maybe this point and this plane I want to create another axis. So now I was using a point and a face plane option. So you can see I made an axis here, right? So there's a bunch of ways you could create these planes or axes. You just got to see like what you're trying to do exactly and kind of figure out how to do it based on the different options that they give you. Okay, so for like a coordinate system, I could add like a coordinate system here, for example, at this point. So you could go ahead and choose the point here, and you can see I have the axis pointing in these directions. And if for some reason you don't like the orientation, you could update it. So maybe you want the x-axis in this direction. You could flip it by clicking this. This will flip your axes, and you could just play around with it and see where you want your coordinate system. So it's sometimes nice to have a different coordinate system, especially if you want to make like a measuring from that coordinate system. Those are all some useful things. And then here, notice that when I created a part, there's a center of mass that showed up. So that's another reference geometry that can be useful. So that's what that is, the center of mass. Okay, so that pretty much wraps up all the reference geometries. The mate reference, we'll probably see that more when we go into assembly, so we won't worry about that now. But at least this will get you started in understanding reference geometries, and then in terms of how you use it later on, more of these features that we'll deal with, you'll get to see. Okay, So if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, we're going to talk about the Hole Wizard feature in SolidWorks right here. So Hole Wizard is a really awesome tool in SolidWorks that lets you create holes that have very specific purposes, like clearance holes. You have threaded holes, you have screw holes, all different type of holes, countersink holes, counter bore holes. So a lot of that we'll get into more with actual designing. Some of that will make more sense to you if you get into design, because it's rather a more involved concept that assumes you know a lot of things. But here we're gonna assume you have some idea of design. We'll save the details of design for another video, but um, we'll go ahead and show you how to use that for the sake of completion. So here you could go ahead and click the hole wizard. There's like other special ones, advanced hole, thread, and then stud. We're not going to worry about those. So you can see hole wizard, if you hover over this, you can see you have like a counter bore, you have a counter sink, you have your hole. Here you have a straight tap, you have a taper tap, legacy hole. This one is a counter bore slot. Here you have a counter sink slot, and then here you have a slot. Okay, so I would say the most common one I use is a hole, and you could choose if you're using inch or metric, and you can specify the type of hole. So you could have a screw clearance, you could have tap drill. There's a bunch of different types, and depending on if you're using, you could choose the size of your screw here, and if you decide to go back to metric, you could choose it accordingly, like 5 millimeters, something like that. So once you choose the hole type you want, you could go to position, sketch the surface, and then you could insert your hole. And when you click OK, it'll create the hole for you. But the real benefit of this is that when you go to drawings, which we'll talk about later on, it's gonna actually auto-populate for you. Okay. So here we'll just take a look at some other holes. Here is this one was called the counter bore, right? You could change the different fitting. Maybe your screw is like really tight. You could change how close. Notice if you look really closely, you can see this hole changing. So if I say like loose, it got a little bit bigger, and then if I do close, it got a little bit smaller. So basically, you could change how that fits, and then you can also do a blind hole like we did for extrude cuts. So maybe you don't want your hole to go all the way through, and you could adjust that. Okay, so you could play around with that, and then you could look here. We'll go through a few more. Here we have like a slot, for example. So this one is really tiny right now, so you can't see it. But here, if I click 8 slot length, you can see that it creates a slot for you. And notice that if you look inside, it'll have the actual drill pattern that it will use based on the tool it's using to drill it. Okay. So there's a bunch of other stuff, right? You could play with this. This is called the counter bore slot. You can see how that looks. And then sometimes you may actually want to configure your head. So you could go in here and we'll actually look at this one. It's a little bit easier to see, but you could see like there's different tolerancing and precisions you could have. You could show custom sizing. So this one's like a giant head here. You could create like a custom depth and so on. Okay, so you could play it. This is like a massively giant hole, so it's not going to work, but you get the idea. You could customize it and make it work for your application. Okay, so that's really useful. And then I think a lot of the details about like which one you use, obviously there's a lot here. It's just gonna come down to that's more of the design aspect. If you choose the screws that you want, then you'll know which ones to choose. So you want to see like okay, is this part something you're gonna tap into? Then you would have a threaded hole. Is this part gonna be a screw that passes through this part? Then you would use a clearance hole. So you need to first figure out what your part is actually doing and then design accordingly based on the screws or different hardwares you're choosing. Okay, so that summarizes the hole wizard tool in SolidWorks. And if you found this video helpful, give it a like and subscribe, and I'll see you in the next one. Okay, so in this video, we're going to talk about the patterns, feature patterns that we have in SolidWorks. So as you recall in the sketch, we had sketch patterns for features. It's a way to repeat any of these features that you've made. So if it's like a boss or a cut, you could repeat that in different patterns. So it's good for just anything that has any sort of pattern associated with it. Okay, so a lot of times it's like for cutouts, or maybe you have something with a lot of bumps as like a pattern, you could do that as well. But here we will just make a little plate here for demonstration. And we're gonna go normal to it and then sketch something. So in here, we're gonna sketch some pattern. This will be our weird looking cat. Okay, so here we have our weird looking cat, and then we're gonna make a cut here. So we're gonna extrude cut through all of it, and we could go ahead and come here. You can see inside this pattern, there's actually a lot of different options. You have a linear pattern, a circular pattern, a mirror, a curve-driven pattern, a sketch-driven pattern, a table-driven pattern, a fill pattern, and variable pattern. So we'll just go over some of the more common ones like linear pattern, sketch-driven pattern, and the circular pattern. So here in the linear pattern, you can see that I can specify the direction, and then this is the amount of spacing. So you can see there's too many, so maybe I want to decrease one. And if I hit OK, you can see that it makes a cut of this weird looking cat, right? And I could edit this feature. Maybe I have a second direction. So I could select this edge here and increase the number of instances and the spacing. So you can see I have a pattern like this. And you could also do other things. So I'm going to delete this pattern for now. And maybe you have some sort of circular pattern. So to do that, we need some sort of axis or point of rotation. So here in my sketch, or actually because I have my origin here, I could create an axis with my origin and the top plane. So this is my axis of rotation. Then in here, what I can do is I can try to have my feature have a circular pattern around that axis, right? So here the features, I need to select this feature, and you can see that it's gonna repeat, right? So notice this like coming out. You could make this sketch a little bit closer just by dragging it. Then you can see that, now it fits inside. You could also have made the plate bigger, but I just chose to bring it inside. So that's for the circular pattern. And then sometimes your pattern may be irregular. So that's where the sketch-driven pattern might come in handy. So for the sketch-driven pattern, what it'll require is points that will specify the location of it. So I could go ahead and go to sketch-driven pattern here, and then you could select the point. Here you can see select a point inside my sketch. Reference point, it could have a centroid, maybe like origin, features and faces. Okay, so here you can see my sketch that I generated earlier and then the cut that I have. So it's going to be replicating in this specific pattern for me. So that's the sketch-driven pattern. And then the other cases is you could have like a table-driven one. If you could, like a specific location, you could fill that out. But you could go ahead and play with that. But I think in terms of the main concepts, that should get you started to create patterns in your models. So here we did it for Extrude Cut, right? You could extend that application to if you had bosses instead of cuts. So the same concept applies. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, we're going to talk about the mirror feature in SolidWorks. So mirror helps you mirror different features inside your parts. So it's good for anytime you have any sort of symmetry and you don't want to repeat it, just take advantage of symmetry. So we're going to go ahead and create a rectangle or a box, same thing. And in here, maybe you have like a special cut. Here, we're just going to make some weird random cut. Maybe it's like solar systems, who knows what, or a deformed Mickey Mouse, maybe. But here, you're going to extrude cuts. We're going to cut these like special patterns. I didn't actually select everything. Yeah, let's just go ahead and select everything. So there's this like weird cut pattern, and then maybe you want it to mirror across. So you could go ahead and create a reference plane right in the middle. Then you could come here and mirror it. Features to mirror, you could mirror this feature, and then the plane is already selected. So you can see it made a mirror image. Then as before, if you change your part here, made it even weirder, and you exit, you see that sometimes you might get a mistake if your cut extrude didn't update. So in this case, you actually have to reselect all the contours. I'm just going to choose something different this time for the fun of it. And you see that it mirrored this weird shape here, okay? So that pretty much summarizes the mirror tool. Again, it's great for symmetry, and that way I don't have to draw this weird shape twice, okay? So if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, I'm going to talk about dimensioning for change. So when you design parts in SolidWorks, there's obviously a million ways you could dimension your parts. But when you start designing more, you're going to realize there are certain ways you want to reference your sketches or certain features in your sketches you want to reference it by so that when you do change your design later on, it'll change accordingly. So we'll go ahead and talk about some examples here. So let's say we're just going to create a plate with a hole in it or some holes. So let's say we have a 1/4-inch plate. And then let's actually go ahead and dimension our plate here. So let's make this 5 by 5. Okay, so we have a 5 by 5 plate here. So let's suppose we wanted to add some holes. So we're gonna just use some metric, maybe some clearance holes. Actually, I'm feeling like inches. Let's do like a number 6 hole. Let's see. Okay, so like for example, let's say we know we wanted to make like let's say we want to make 4 holes, right? Do you think this is the best way to make the 4 holes? So right now you can see that, one way of dimensioning this could be, what if you just made each one like 0.5 away, right? So notice if I do this, if I repeat that for all four, that would take a lot of time, right? So another way you could do it is, let's say we put it in a square. So we could draw a square. And instead, we could lock it to the corner. That way, if we did reference it to one side, we only need to do it once. Okay, so this is another way you could put it in a square. Because a square is not used, we want to use a reference. So notice right now that, let's say, for example, we know that this will be 4 inches away. Okay, let's say this is a 4x4. And suppose, you decide to come in and say this is going to be like ½ inch away, right? So what do you notice is wrong or not good about this? So we're dimensioning this top corner to be um, zero point 0.5 and zero point 0.5 away. So if we ever decide to change this part, notice that this whole thing will be referenced to that corner. So what do I mean? If I come here and change this, right? If I one day decide to make this 7, right? You'll notice my holes get shifted. So unless you initially wanted your holes to have this specific pattern, you would dimension like that. But let's say you always wanted the holes to be 0.5 from the corners, then you would actually dimension this differently. So if you go into your sketch here, if your intention is that each point is 0.5 away, then what you would want to do instead is you don't want to fix this dimension, but rather maybe have the center of this square inside. So one way to do that is you could create like a center line, and then maybe add a midpoint in here. And then this midpoint would be coincident with this. So now, or actually it doesn't like a point because Hole Wizard will see that point and make a hole there. So I'm gonna actually delete that point and then make it a midpoint. So you could make a midpoint relation without a point. So there you go. So now if I come back here and, if I decide to change my plate size, you'll notice that the holes will follow accordingly, right? So there's really two ways or two common ways that someone might make hole patterns. They may make a pattern such that it's fixed, or they make a hole pattern that's like dynamic to the plate size, right? So depending on the application, you would dimension it the correct way. Okay, so you want to think about how your design could change later on, and based on how that change might happen, you want to dimension it based on the feature that that won't or will change. Okay, so another example too is, let's say right now we have a thick plate, okay? And let's say we always want a hole. Let's say we want to cut a hole here. So we're going to go ahead and do extrude cut right in the center. And let's say this hole is 3 inches. Let's say we make some cut, okay? And let's say the cut is like 3 inches. So notice here, if we measure this, right? Let's go ahead and convert this to inches. You could see here, this is inches. So we have 2 inches, right? Because it's a 5-inch block and we did a 3-inch cut. So let's say we want there to be one inches of space here. So if we edit this and do 4, right? Then if we measure this to the bottom, we're gonna have 1 inch. So now let's say we always want to maintain that distance. Actually, let me change this design a little bit so we can see the cutout. So I'm going to go ahead and make this cut like so. And I'm going to make this, let's say 0.5. So the build crashed, so I edit, select my contour, come in and choose this. Okay, so notice we have a cut like this, right? So we have a cut, and let's suppose that we always want the distance from here to here to be 1 inch away. Okay, so how can we dimension this such that if we modify the thickness of the block, let's say we change it to 3, notice how now it's cut all the way through, right? But let's say we always want there to be 1 inch of material. How can we do that? So the way you would dimension this correctly is, let's say we added a plane here, and let's say we made that plane 1 inch, and we want to flip the offset to here. One way you can do this is if I move the plane above here, or move the cut down. If I edit my feature, I could say you could dimension it up to a surface, right? That's one way you can dimension the extrude cut. So now, if I come to my extrude boss, and let's say I wanted to make this smaller, like 3 inches, notice that there's still 1 inch of space here, right? If I come here and measure it, you see that this is 1 inch. So that's exactly what we were shooting for, right? So the main idea is if you're trying to design something for change and you know certain parameters you want to maintain, then you should dimension it such that when you do change a parameter, that your design will hold the dimension that you want. So as a recap, in the first example, we talked about how to dimension these 4 circles if we wanted to change dynamically with the size of our square. And then the second example we talked about was, let's say we wanted a constant thickness of 1 inch of material left, regardless of the thickness of the square, then you would want to set up a plane and dimension it, do the extrude cut up to the plane. That way, when it does change, because the plane is dimensioned relative to the bottom and it's 1 inch, then it'll always be 1 inch. Okay? So as you design, just always keep in mind how you're going to change your part. And then when you dimension, you want to dimension it accordingly. So there's no hard and fast rule. It's just you gotta have, design more, have more experience, and then you'll see what's the best way to design without all your dimensions breaking. Okay. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one. If you want to bring your parts to life, PCBWay is the option for you. Go ahead and come up here to CNC 3D printing and choose 3D printing or CNC machining. Here I'm going to go through the 3D printing process. All you need to do is drag your part into this area here. So I'm going to drag my STL file. Once you do that, you could select a quantity. Here I'm going to choose 1. Now go ahead and fill out the remaining sections with a red star and then submit your part for review. Okay, in this video, we're going to talk about assemblies in SolidWorks. So assemblies lets you put different parts or other assemblies inside an assembly. And then the assemblies that are inside the main assembly, we usually call that a sub-assembly. So to create an assembly, you go to File, New, and then you could choose Assembly. Okay, so when you create an assembly, you're going to see this window here pop up that says Begin Assembly. And there's a pin button that will make this tab stay visible. That way, when you put a part inside, this thing won't close off. And in this example, we're going to go ahead and create a motor bracket that mounts a stepper motor onto the motor bracket. So here we have a stepper motor that we got from McMaster. So notice when you click once and you have this pin open, you could insert multiple parts, for example. I could also insert multiple screws, and then you could hit escape to leave this, and then the ones you don't want, you could select it and then hit delete, and then you could hit yes to all. Okay, so that's how you would go ahead and delete it. And then you can move your parts around by just dragging it. Inside here, you could see there's like a move and rotate component, so you could rotate a part. And there's like different drag options, free drag about entity by XYZ. I usually just do the free drag, but you could go ahead and play with other options. And you can also do like collision detection. If it like senses something, it's gonna bump and then stop. So those are just more advanced. You don't have to use those. That's just for special things if you want to be fancy. But the normal free drag should be good to go. So the assembly lets you put in like different parts, right? Like we did right now. And then you could also hit the control key and drag to create copies. That's like one way of doing it. And then I will use them later, so I'm just going to delete it for now. And then now we're going to go ahead and make our bracket. So here, if we look at our motor, if we check the size, we were working with this thing is like 2.25 inches. So we're going to go ahead and create something that is like 3 inches. And then extrude boss thin this. Make this also 3 inches perhaps. And we'll make it 0.125 thickness. Okay, so this is just some brackets. Put it in our assembly folder. Okay, and then you can also come in here and just drag and drop. That's another way you could insert a part. Okay, so notice right now everything is floating. You could also right click and select fix, then you can't drag this part anymore because it's fixed. So sometimes I like to use the fix to play around with that. And then once you want to move it again, you could choose float and then it'll move around. And sometimes if you just want to look at one single part, you could right click and hit isolate, then it'll make the other stuff disappear. And then you could hit exit isolate to come back to see your part. Okay, so one of the key things with assemblies is I like to orient things in based on the planes I'm working with. So in one of the following videos where we talk about mates, I'll go into more details about that. But for now, let's just consider like looking at an assembly. So when we talked about moving assemblies and then also inserting parts inside the assembly, you can also come to Configuration Manager to create a new configuration of your assembly. We'll talk about that in another video. And then in here in the assembly tab, you can also do like linear patterns. So those are similar to the feature patterns that we did. And then there's like different reference geometries you could do. We could do exploded views. These will be all topics we'll talk about later. And you can also create sketches in your assembly if you wanted to. So usually these might be like certain references you might want to make in your main assembly. And then markup if you want to draw stuff. I don't really use this too much. Evaluates, you could have like mass properties to see like the weight, volume, and moment inertia of all that if you're interested in those information. And then there's like sensors if you want to like keep a measurement of something in your design. You could check for interference or clearance. That might help if you have any issues with your design. And then there's like other visualization tools, performance evaluation, costing, and other things that can help support your assembly. And then stuff with like PLM, if you have like version control or management, there's also add-ins you could play with. But that's pretty much it with assemblies. So once you have your part in there, the key thing is how to mate them correctly. So we'll get more into the mating part in the following video. But one thing to make sure of when you're creating assemblies is you want to make sure that your parts will fit into your designs, right? So in this case, we inserted a bracket, and then if you want to mount something, you need to make sure that everything can fit. So in this case, we have some mounting holes. If we measure this, we'll see that the distance here is, let's drag this. Let me measure this again. Distance is 47.2 millimeters or 1.86. So we could change the units here. Units and precision. Let's go to 3 decimal places. I usually like to do 3. And you can see this was originally designed in millimeters, so we could go with 47.2. So in here, we could go ahead and just modify that real quick. Go to Hole Wizard, and we're using a M5, so we're gonna have a M5. Let's go to metric. We're gonna do a tap drill, M5 position. We're gonna go ahead and draw our square. Delete that point. And we will place our 4 here. And then our dimension was 42.7, right? So let me check this. Would you like to rebuild? So we're going to let it rebuild. So yeah, we have 47.2, right? So if we come back here, you could edit your sketch. And then you could dimension this to be 47.2 millimeters. And we can set this equal to this dimension. And then right now we want this to be centered. So maybe I'm just gonna create a line like this. And then gonna click this point and then hit midpoint and exit. So now you can see we have our bracket that will fit. So that's definitely a precursor. Is before you assemble anything, you need to make sure that your part is ready and it will fit. Okay, so here we're just gonna have this as our threaded part and then mount this onto here with these 4 holes. Okay, so we're gonna save this as our motor assembly. Okay, and then another thing that you can do is if you later decide you want to insert new components, you could insert here, or you could also insert a new part inside this assembly. So you could do something like this and start sketching something, for example, and extrude boss it, perhaps like this, and exit. Then here you see that we've made a new part inside. Okay, so that's another way you can make a new part. But because we don't need this part, I'm gonna just go ahead and right click delete. So that's how you can remove a part. And then sometimes when you're visualizing inside assemblies, you may want to change the color of your part. So you could edit appearance and then you could choose your favorite color. Maybe the motor is black and then the appearance of the bracket might be, this one is, you could edit the appearance of the motor bracket. Okay, now the motor bracket's selected. Could choose a different color. Let's do green. So these different colors can help you visualize better, especially when you have more parts. Okay. And then one last thing is we need to have this dimension here. So notice that this dimension is not being updated. If you go to evaluate and measure, we could check here again. Okay, so when we measure this, we see the diameter is 38.1 or 1.5. So in here, we need to make a hole of that size. So if we go normal and then sketch, can make a 1.5. And if you want to consider tolerancing, I'll have some more videos about tolerancing. But for now, let's say we have a 1,000 tolerance. And you want to center this. So we're going to make a center line here and then choose this point and then make that midpoint. And then extrude cut all. So usually motors, they'll use like the center part for locating the center, and then they'll use that main feature to locate that. Okay, so we won't worry too much about the specifics on how to like assemble specifically motors. We'll have another series that talks more about like the nitty-gritty details of manufacturing and designing for like mechanical parts, but here the main focus is just like on using SolidWorks. So I'll go more into details that later, and you could comment below if that's something you're interested in too, and I could go into more details. But for now, I think we're pretty much ready to mate, which is going to be the key part of assemblies. Okay, so stay tuned, and if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, so in this video, we're going to talk about mates in SolidWorks. So in the last video, we talked about using assemblies in general, and we just kind of talked about getting the parts ready for assembly and different things to consider, and as well as the different buttons that's available inside assembly. So here we're going to actually talk about mating. So mating is really the core of assemblies because mates are what constrains parts inside an assembly, and there's obviously a million ways to mate something, but there are certain ways that I prefer to make things a little bit easier for myself. Okay, so right off the bat, you have views that you work with, right? So you have a front view, you have like top view, and so on. So I typically like to mount my parts as if I were looking at them corresponding to those views. So for my front plane, I would want to mate it so that it looks like I'm looking at the front when this is in the front. So I'm gonna call this, I wanna have this motor like be on its side when I'm looking at it in the front view. So to do that, I need to mate one part that's considered constrained or like fully defined. You can see these minus signs here by the parts. That just means that they're floating. When I fix them temporarily, you see fix and then you can't drag them, right? But the proper way is to not fix them, but rather mate them properly. So like this part, for example, if I want to constrain it, I want to constrain it to one of the planes. So I could either use use its planes and mate with the planes of the assembly. So these are the assembly planes, the front, top, right. You could mate the part planes to assembly planes, or use like certain sides of it and mate it to the plane. But here we're just gonna right click the two top planes because top is top for both of them, and then we're gonna make it coincident. So you can see the mate types when you choose the two parts and how to mate it. So we'll go into different ones later on, but these are pretty similar when we were choosing relations. So the complement of relations and sketches for assemblies is mates, but they're typically the same thing. The same concept carries over. Okay, so right now the top plane is made it properly, and then here we have our right plane. So the right plane is also actually going to be mated to our right. And then you could flip the direction here, the mate alignment. So I just want the motor to be pointing the other direction. And then the last mate, you could try dragging this now. So notice that I can only drag back and forth. If I try going right and left, it won't move. And then if I try dragging, if I look at it from the front and I try dragging it up and down, you see it doesn't move, right? So right, left, up, down, you see it's not moving. It's only going to move back and forth. So this last mate that we have to take care of is the front plane, and we're going to mount it to this front plane. So if I mate that, that's a total of 3 mates for this object, and you can see the minus sign disappears. So what that means is that this motor bracket is fully defined, and if I drag it anywhere, it's not going to move around. So now if I come in and then hit like front view, the motor bracket is exactly how I want it. I go to top view, is exactly how I want it. And then my right view is exactly how I want it, and so on. Okay. So now to mate this motor, you want to click one of the edges here, right? And then you can click the mate button. So you want this to be, if I click that, there's different options, right? So by default, it guesses as concentric. So that will make the 2 circles aligned. That will be the best choice. So because it's a circle, it's concentric. And notice here, sometimes when you're assembly, you might notice like, oh, something's not fitting, right? You can see an interference. And usually this tool with like interference detection, it might also tell you. If I try this, if I try calculating, you can see that it's saying there's like interference. That's one thing you could do to check, but it's good to be able to check things visually by eye, just with practice. But in this case, right, I'm gonna save this real quick. In this case, you could see the conflict here, and you could go ahead and modify this part, make the bracket a little bit taller. So this was actually supposed to be 3 inches. So now if I come back here and it rebuilds, you can see that the spacing changed. So that's what we want. And then the next mate is, notice that this thing can rotate. So we'll want this face probably parallel to the bottom face, like so. Notice that there's a cable there, so maybe you want the cable on the side. So I could try to have the cable pointing away because I don't want to see it. And then you could mate this top plane to this plane. And notice that by default it goes to parallel. Coincident doesn't work because it's already constrained by the circle, so there's no way for those 2 planes to be touching. So the only way you could mate it is by using a parallel mate. So now you can't rotate it, and it's constrained to a circle. You can only move it in and out. So that's the only range of motion. And then from there, you could finally choose this face and then mate it to that face. And I did that pretty quickly, but what I did was once I clicked the 2 faces, I could right click and that will do like the check mark to allow the mate to finish. So that's how you mate the 2 parts here. And then you could go ahead and mate this screw. So what you want is to have first a concentric mate here. So notice there's like other mates like tangent. So I could do something like mate this plane, mate it here, and I could make this tangent. That's obviously I wouldn't do that for this application, but it's just for the purpose of showing. So you see when I drag this screw is tangent. So that's how you work with a tangent mate. And then if you screw up with your mates, you could come in this tree here and then just delete your mate here. And then the tangent mate will go away. So now this part is again free to move. So here I'm going to mate and then choose this to make it concentric and right click to confirm the mate. And then I'm going to click this face here and then right click to confirm it. So now you can see I have added my screw here. Or actually I could, this is a through hole. So this is a through hole. So I could have like a nut behind here, or another way is I could make this plate threaded. I think I initially made this plate threaded so your screws will actually go the other way. So again, let's say you want to change your mates, you could come in here, edit feature, and you could say like, okay, I want to change the face. So instead of this motor bracket, I'm going to delete this, and you could come in here and modify and say you want this face instead. But now notice the direction is wrong. You could click flip mate alignment, and then now it might be in the correct direction. Okay, so you could mount something like this as well. So obviously the screws are sticking out. You might choose a shorter screw for better sizing, but this is just really to show the demonstration of how to mate it. Okay, so once you get one screw in, there's like another feature that's called copy with mates. So what this does is allows you to repeat mates. So the only thing repeated is a coincident because it's sharing the same surface. And then the part that changes is a concentric maze. So you could click the new one you want and then right click and then repeat that 4 times. So this is a quick way to add multiple parts, inserting it in and adding mates at the same time. So now we have all 4 screws inside our assembly here. Okay, so that pretty much wraps up mates in SolidWorks. So whenever you want to come back here, you could play with your mates, and like parts, you could also suppress it. So maybe one day you wanted to make this rotate again, so you could come in here and suppress the mate, and then this will start rotating. Okay, but if you could unsuppress this, and it'll go back to the right mate that it had. So that's a pretty useful tool too. Okay. So hopefully that gave you a good idea on how to use mates in SolidWorks. So just remember that mates are good for helping you constrain your parts, because you can see now that at least these two don't have the minus sign. The screws usually will have the minus sign because it can still rotate, but no one really cares. So we usually don't bother trying to constrain the rotation of the screws. But this is pretty much it for assemblies. And if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, we're going to talk about section views in SolidWorks. So if you go to this little button here, you'll see the section view. So section views are great if you want to see what's inside your assembly. So you could click section view, and then right here by default, it's doing a section view from the front plane. So a lot of times when you have like more complicated designs, you want to see how your part is fitting in certain parts. So you could click the check mark and you can see your part in half. That way you can see exactly where everything is touching in your design. And to exit the section view, you could click this button and this will let you exit. Okay, so you have these arrows here that can let you adjust the plane, and you can also adjust the plane here as well. But there's like these different arrows that you can adjust the plane of, so that will allow you to cut in different directions. And you can also just reset this to go back to 0. Just gonna do everything 0 here to reset everything. Okay, and you can also usually you'll specify the exact amount. You could do it like that. And then you can also change the different planes. So you could be cutting from the top plane, or you could be cutting from the right plane. So there's different options depending on which way you want to cut. You can also do more than one plane. So maybe you could add a second section that's from the front. So you could cut into a portion of this if you wanted to see a certain part. And you can adjust it by, going back to, maybe I want to see this much. And then you could click OK. Then you can see this is your new updated section view. Okay, and then another technique too that I like to use is sometimes if you know the plane you want to section view, you could actually go ahead and create a reference geometry plane right where you want it. So if you actually click this plane here and go to section view, and the distance will be 0 because it's on the plane, then that will be the plane you're cutting in. So unless your assembly is already in the right plane, you could create a new plane and then do your section view. Okay, so those are some techniques you could play with. And then you could see here, there's like other options to transparently section components. I usually don't use this, but the main thing is the top view here that you could do. Okay, so that's pretty much it for section views. It's going to be really great when you get into more complicated designs and you need to see how your part fits in special places or check for interference. So I highly recommend you playing around with the section view. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, so in this video, we're going to talk about exploded views. This is this little button right here called exploded view. So with exploded views, what this does is it sets you ready for assembly drawings, which we'll get into in a little bit. But for for exploded views, what it does is it drags different parts away, and then typically you have different steps. So you may drag a part in a few steps and another part in a few more steps. And typically, how I like to do this is I'll drag it. I'll have like one main part that's fixed, and I try not to drag that one, unless it just makes it easier. But typically, I'll try to keep my fixed part fixed, and then just drag the other parts. So there's like different techniques of selecting. You could select from upper left down to right, or you could also, let me just clear this. You could also drag from bottom to the top. So bottom to the top will select anything that's in scope, and then top down will select only the parts that's inside. So let's say I want to move the motors back along with the screws. I can select everything and then deselect the plate. Then this will allow me to drag everything. Okay. And typically the amount I drag really depends on I usually like to go to the isometric view to see how much I'm dragging, and then I'll typically drag enough so that I see some spacing. So notice that if I drag about this much, right, you see a little bit of gap here. So that's usually what I shoot for. And that's personally just me. I like to have things space out pretty nicely. And you're not limited to dragging like only this direction. You can also drag it the other way as well. So here, I just exited my exploded view, but let me just repeat this, right? So I select everything, and then I deselect this, and then I drag it out about this much to have the space, and I hit OK. Then you can see that my exploded view has been done. And if I right click here, I should be able to see my view. You can say explode. Okay, so that should give you your exploded view. Inside, you can see there's the exploded view here. Let me just delete one of them. So this is how you go to your exploded view, and you could edit the feature if you're not done. So if you want to add another step, you could just start selecting again. So here I want everything except the motor. So notice I could drag this way too. And let's say that wasn't a step you want, you could delete it. Okay. So I'm going to select this again, everything but the motor, and just drag back. So this is how you would do assembly, exploded view for the assembly. And then there's also this thing called the exploded line sketch. So what that does is it shows you, especially for circular components, you want to see how it lines up. You could connect the two things and it'll line up. And notice this arrow is pointing in the other direction. That's why you get this like funny looking like zigzag going on. So to fix that, you could change the direction of that arrow. And now you notice you have a nice straight line. Okay. So you could do that for your other things. So you can only do one at a time actually. So I'm gonna delete this, delete this as well. So you have one line. And then once you click OK, you could choose this other one. I'm gonna flip it and then do this line and hit OK. And then just repeat that for this one as well. And this last one here. Okay. So that's how you have your exploded view lines. And this is great because it helps you visualize to see how everything comes together. Okay, so we could come back here. Let me just exit the sketch. But if you come back here and you try to edit your feature, notice you could come back to modify your steps. You could maybe specify an exact distance you want, maybe 7. And then here you could say like 7. So you could be very exact with your spacing. And you can also come in here and say like, let's say you wanted to animate the collapse to see how it collapses. You could animate, and you can see the parts coming together. Okay, so that's pretty cool. And you can also come in here and then hit explode, and that will explode it back out again. Okay. So that's how you do exploded views in assemblies. And then when we get into assembly drawings, we'll see how some of this comes into play. And we'll talk about that in the next few videos. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, we're going to talk about drawings. So drawings in SolidWorks, the point of drawings is when you have a part made. So let's say we're looking at this part here. We're going to go back to a small configuration. But let's say we have a part made and we want a drawing for this part because someone wants to manufacture it. And because we're not 3D printing, for instance, someone needs to know the location of everything about this part. So to do that, you need to create a drawing. So there's a couple ways to get there. You could do File, New, and then click Drawing. You can also right click and then open drawing, and there's no drawings, it'll create one for you. But let's go ahead and just do File, so it'll be File, New, and then Drawings. So when you create a drawing, there's a couple of options here. So typically there's like these different sizes. The B size is pretty standard for part drawings. And then you have the D for like bigger ones, like assembly drawings. So we're going to just choose the B. So this is the idea of a drawing is you have your part here, and then you also have your different parts you want to add in. So you could add in like a motor bracket, for instance. You should be able to see your view palette and select motor bracket. And then you could start adding your views. And you could right click and project view to get the other sides. Okay, so this is like a quick view of the drawing. And I'll go into more details about actually making a drawing later. For now, I just kind of want to focus on the different parts of a drawing that you're dealing with. So um, I went through this part pretty quickly, but let's just say we already have something in place here that has your drawings, right? So once you have your drawings, you typically need dimensions. I'll talk about the actual dimensioning part in another video, but for now, we're just gonna go over some of the tools that's available for you. So you have different things like projective views. So you could click this and then like project it in a certain direction. That's projective view. You have things like section views. So you could click here and then move over. You can see the section of this. So this might be useful if there's like a certain part of it that you need to see or dimension more clearly. You could have like detailed views. If you zoom in here and then click here, you can see like a specific part of your drawing. So these are all different things. And this is case by case. Sometimes you'll need it, sometimes you won't. Just really depends on how detailed that part is. And then you also have like a break view if you have like a really long part. But for here, I'm just going to do like a simple example. You could break it, and then you can see that it'll only show the parts outside of the break. But again, breaks are usually good for like really long shafts. So those are some of the main things that we use pretty often. And then in the view layouts, you have, we just talked about the view layout. These are pretty similar. It's like the different views that's available. In the annotation, you have like the different tools that you can use. You could have, if you're dimensioning the parts, there's like different ways of dimensioning. Some people use the ordinate dimension. If it starts from a 0, we'll talk about that later. You could sometimes add notes up here on the top. So you could say like, make my part pretty. You normally won't say that, but just as an example, you can make like more appropriate notes might be like, oh, remove all sharp edges or something like that. But or if there's like a certain finish, you might say that as well. So you might use the notes for that. And you have like different things like center marks for circles, center lines. If it's like a cylinder part, you might need to add a line in between. Datum, if you have like some flatness or certain references to a certain surface, you could use that as well. Okay, and then sometimes you might need some sketches to help you out. You could add sketches manually. You could evaluate different things. I usually don't use these other tabs. So these are like really the main ones that you need to know. If you run out of space, you could also add a new sheet here, add sheet to continue your drawings. Okay, and if you don't need the sheet, you could right click and delete it. Okay, so this is like a quick overview of drawings in SolidWorks. In our next one, we'll actually talk about creating a part drawing and going into the details of it. But for here, I just wanted to show you like a quick overview of the different settings and options you have in the drawing view. So stay tuned, and then we'll go more into details on how to make the drawing for this part. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, we're going to talk about part drawings in SolidWorks. So last time we just talked about drawings in general and the different things you have at your disposal when you do make drawings. But for here, we're going to go into more details on how to make a drawing pretty much ready for use. Okay, so I'm going to delete this little text box because we're not using it. So let me just go over this procedure once more. Gonna delete everything. So when you come here to this view palette, right, you want to refresh to see your part. And then once your part is in here, you could right click and then go to project view to get your other projections. So the way you decide how many projections you need, you want to see what sort of features you have, and then what sort of thing will give you just enough information to design your part. So, like, for example, if I have these two views, do you think this view is necessary? So the way you could figure that out is, okay, this only tells me two dimensions, right? I could really get these two dimensions from this length and then this length. So in this case, this doesn't really present anything new. But one thing it does tell me is if I'm looking at, it can confirm that there's nothing on this face. Okay, so this is kind of useful, but not 100% critical. Typically, 3 views is really more than you need. Like, for example, if I added like another view like this, it doesn't really add anything new, okay? Unless there's like a hidden feature that I couldn't see. Or like if I went ahead and added another view on the top, this really doesn't add anything. So I would say in this specific case, really, 2 is the minimum. 3 is maybe you need it, just so you know there's nothing, but you could get away with 2. And sometimes drawings by default can be a little small, so you could go ahead and change your scale if you want it to be a little bit bigger. So if your scale is not here, you could use a custom one, and you could just type it in. So here it's going to go to 1:1. And you kind of play around with when you actually start dimensioning it to see how much space it takes up. I'm just going to actually delete that one just for sake of spacing. So you want to position it so that it looks nice and spacious. And you could dimension it a couple ways. In this video, we're going to go over the ordinate dimension. So you could like right click, or actually in annotations, you could do smart dimension, ordinate dimension, and then you could click one side, right? And then you could click like this to see all your dimensions. And then you could do order dimension again and click one face, that's going to be your 0. So you can see that this fully defines the sketch. And sometimes maybe you would start like the 0 on the other end for this if it makes more sense to you. That way you can see the thickness more easily. So that's kind of a preference if you think about where the 0 is located for the person. Okay. And sometimes you might see like a smart dimension and just come in here and say like the thickness. But in this case, that would be duplicate. So really, this should be suffice to fully define this. So really, to dimension your part, you really want to fully define your part. And then a fully defined part in like your config when you do like your solid modeling, it'll be, you know, you'll see like the blue lines turn into black line. That's essentially the same concept. Okay, so here we're gonna add some more ordinate dimensions. So for here, you can see we add some holes, and then typically because we already know the length of this plate, you don't really need this. So this could be omitted, or you could add it in here and like add parentheses. That's what some people do. That really depends on the convention of like the place you're working at. So we're gonna go ahead and do this, something like that. And again, these are like duplicate dimensions. So maybe you could just hide it. Actually, this one is the depth of it. So you actually don't know this one. This one you know from here because you have this dimension, right? So that is given to you. So this one you could add like a parentheses in here. For example, this one right here, parentheses. So sometimes the parentheses is like repeated. That's what it means. So for these, right, you could say because these dimensions are repeated twice, sometimes you might see like a 2x here. That would be like one way of showing that you have two instances of this whole dimension here, okay? And then you could add like a hole call out here. There's like one hole here. You could pull it. So you can see you could pull it at many different places. I typically like to just pull it somewhere that makes it look pretty. And by pretty, I mean just like nice and spaced out. So you can see these hole dimensions, what it'll tell you is one is the diameter of the hole and then the depth. So here's a 1.5-inch through hole, and then here is a 0.17, and the depth is 0.47. So notice that when I made this, I didn't make it a through hole. That's why it's showing 0.47. So I could actually open the part and try to edit this. And if I come here to my tap drill hole edit feature, I should see that this was actually a blind. So a more appropriate one would be to make it a through hole. And then that way, if I come back into my drawing here, you can see that this got updated to through all. Okay, so through all is a little bit cleaner because it doesn't make sense to do blind when it's actually a through. So that's where that would come in. And notice that all these dimensions are to like 2 decimal places. If you have like very precise location, sometimes you might want to actually up it to 3. And this is in the document dimension. So it's reflective in your options, document properties, should be in dimensions. So here it's sometimes good to have it in 3, especially if you're doing more precise drawings. So you should notice that all the dimensions now reflecting 3. So when you're actually designing for manufacturing, sometimes the actual tolerance matters. And in this case, you could have something like bilateral, which could be like plus 0, minus 0. You could have like symmetric. So here we're just going to do like plus or minus 1 because maybe we want it to be in a very precise location. That's just an example, but in this actual application, it may not matter, but in some applications where the location does matter, you want to do that. And same with like the hole diameter. Let's say this is like a slip fit. You could do like a bilateral, maybe like a plus 2, minus 0. That would be like the tolerance. So it'll be above 1.5. It'll be at most 1.503 and at least 1.501. So there's like a guaranteed small gap inside the part to fit. So if I look at this assembly here and then, if I zoom in really close, you should see like a very sliver gap in between. It's a little bit hard to see, but if you zoom all the way in, there should be like a small gap here. Okay. But the point is like when you have this drawing, when you make the drawings, you want to make sure that this gap is guaranteed so that your part will actually fit correctly. Okay. So once you have dimensioned everything, we have the key dimensions, we have the key lanes, we have all the holes specified, and you have these like center marks for your holes. Sometimes if the center mark size is not quite what you want, you could, change the mark size to your wishing. But in this case, we'll leave it as is. So that's pretty much how you would make a part drawing. And then to put the cherry on top, sometimes you may want to add in like a isometric view somewhere in the bottom. And this just kind of summarizes what the final part is. Okay. And then we also talked about like the notes. You could add notes if it's special instructions or there's like more advanced stuff that we'll get into in a different series. But for now, this should get you started in just creating a drawing to begin with. And there's like other things you could fill out here depending on the specifics of your company or whoever is doing the drawing. They might have certain ways of filling this out, so you want to see what practices they do. But at least for now, you're able to create a drawing in SolidWorks for a single part, and hopefully you can send it off and have someone manufacture for you. And then there might be some back and forth between the like machinist and the design engineer if something is unclear. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one. Okay, in this video, we're going to talk about assembly drawings in SolidWorks. So last time we made an assembly with a motor, bracket, and screws. And in this one, I actually swapped out the motor because when I saved my files in Makers, it tried to save in the cloud, and then somehow I couldn't retrieve it, so I ended up remodeling it. But anyway, this one is slightly different. If you look at the motor, the holes here don't go all the way through, and you can actually see threaded holes in the motor. So that actually makes it a lot easier in terms of figuring out where the screw should go. But this actually has a M3 screw that goes in, and then everything else is pretty much the same. This is still a stepper. But the prerequisite for making an assembly drawing is to have some sort of exploded view to see how everything is supposed to assemble together, and when necessary, you could add the exploded line sketch like we have here to show how everything is connected. Okay, so once you have that done, you could check out my previous video if you missed that, but once you have that, you could do File, Make Drawing from Assembly. And when you make drawing from assembly, depending on the size, you could go with a B or a D size. C is a little bit longer. We usually like to have the more rectangular shapes, but for this one is small. I'm just gonna use a B size for now, so I'm gonna hit OK. So once I hit OK, you see that there's this option here that says isometric exploded. So I'm gonna drag that in here. So notice that when you drag in, it's pretty small. So SolidWorks tries to figure out some size, and if you don't like it, you could choose your own scale. So there's some custom ones. If you do like a 2:1, you can see this is gigantic. So you could just kind of guess and check to see which one's appropriate. You see that's a little bit too small still. So you can see that's way too small. But if I do like a 1:1, I think this is a pretty decent size. Yeah. So I kind of like the size. I'm gonna stick with it. Notice that this long cable is just sticking out. We could modify it in our model here if we wanted to. So I could, um, if I don't want it to stick out, I could go ahead and open the part. And maybe I could make a sketch plane here. So I'm just gonna sketch some circle. And then I'm gonna cut this long cable out of the way. So if I come back to my assembly drawing, you can see the cable is gone. Okay, so I'm just gonna do that because it looks cleaner. But the main thing with assembly drawings is to know the number of parts you have in your drawing and how things are connected. So one thing you notice here, this a pet peeve of mine, is when parts overlap. So when you have cases like this, it's actually better to space it out. Um, in this view, you actually can't see it, or actually now you can see it, right? So if you ever see things don't line up quite the way you want it to, you could come back here into your exploded view and then you could edit your steps. So I'm gonna edit the feature, and it was the first step here. So that's why when you do make your assembly, um, when you make your assembly exploded views, it's always good to view it in the same view that you're going to create your drawings in, which in this case is isometric. So you can see now it looks a lot better. And it's because I remade it, I didn't check that. But previously I did check it. So here you can see it's a lot better. It's nice and spacious. So once you have that set, you could come into here to the annotations. So typically you'll have you could use what's called balloons. So for each unique type, it's gonna have some number associated with it. And then you can see that there's a total of 3 parts. So you basically just click and drag. And sometimes people like to line it up. Notice that here I have this arrow pointing to the inner one, but if it's the same, it's actually better to point it to as close to the balloon as possible. And same thing with this, like you don't want to have the arrow like pointing all the way across. Try to have it point as close to the balloon as possible, and that just makes the lines shorter and cleaner. So again, those are all I would say style techniques. And sometimes I like to have the balloons kind of line up a little bit. You don't want to have it like drag out the other way or like in all sorts of weird directions. I like to try to have it centered and aligned just so it looks pretty. And you can see here sometimes you'll get like this ugly zigzag. I don't know if you can see that, but I'll like drag it until it's kind of away. Okay, this just made it worse. So sometimes if you play around a little bit and it's not looking better, you just gotta not be so OCD about it. I am a little OCD about it, but I think for now this looks okay. So once you have that, you could insert your table and you could have what's called a bill of materials. And it says select a drawing view to specify the model for creating a bill of materials. So you could just choose your drawing view and then you can hit OK. And then bam, you have your BOM, your BOM, bill of material. So here by default, there's part numbers. So these I got from McMaster. So the BOM is great if you're trying to order items. Um, yeah, you're trying to make like a final list of the things you need to order and how many to order. So here, obviously, it's 4, but when you're ordering screws, they never really come in perfect number of 4s. They usually come in packs. So you have to use your best judgment in terms of how to order that. But basically, this gives you all you need to have a list of all the parts and quantities you need to order. So our motor bracket here was a default part. So you could come up with some part number naming scheme as you wish to keep track of that. And then you could update the description to be what it is. So I just didn't update this field, but you could go ahead and update it. So if you open up your part, let me see if I right click, open part, I could go to file, properties. So here you can see I could have like a description. So I could call this motor bracket, and then I could have a part number. So I call this 0001, for example. So if I minimize this, and then if I come back to my assembly drawing, let's see, this rebuilding help. I don't know why I did an update. Let me see. So if I come back here, so yeah, we were saying that the description and part number will be updated. So right now, probably the best way is to go ahead and rename your part with a part number. Then it'll show up in the part number field. So that's like a way around it. And some other things you could do with the bomb table is you can see here it'll show you, if you look closely, it'll show you which ones you've actually had a balloon for. So, in case you forgot to add a balloon for this guy and you come here, you'll see the balloon missing. Okay. So that's like an easy way you can check if you did everything. And you could also go ahead and if you want to insert more things, you could right click, insert a column, and you could add more properties, for example, unit of measure or something. And if you change your mind, you could delete the column. Okay, and you could drag and place your table anywhere. But typically, I like to have it somewhere in the corner and then try not to let it overlap anything. Okay. So that wraps up how to do assembly drawings. So hopefully, once you have this, another thing is you could actually add notes up here like we did with drawings. So add your notes here. So if you have any special instructions, you could add it there as well. Okay, and there's other stuff you could draw here too that we won't get into this video, but if needed, you could use these other tools to make your assembly drawings more specific or if you have any special instructions. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one.